every time I work with developers, I find out they're using procedures. And I thought one of the most effective discussions that I could have with you tonight is to try to convince you that always and never are really bad words to use with SQL Server. Recompilation is not always a good thing, it's not always a bad thing. So I have a couple of things I want to show you, a couple of demos I want to do. They said I could have 20 minutes. I could do demos or whatever you guys have. I decided actually while I was sitting back there that I'll actually have some slides. I'll put them up on my blog tomorrow, and I'll even put the code that I'm demoing on my blog and the database I'm using for my samples. You guys can download to reproduce my code as well. So you'll be able to redo everything that I do tonight. If you have any questions, my email's up here. Of course, you'll need to get to the blog, so you'll have to kind of remember a little bit to get this far, but you can also send me email if you can't find something or you have any questions. So I'm going to go really quick with the intro because I want to get to the technical stuff. That's why I know you guys are here, and I'm assuming that you'll have a lot of questions on this topic too, because I might end up telling you something that maybe you didn't believe in the past, and I might be giving you a different perspective on things, and so you might end up really wanting to look at this code and play with it. So. My name is Kimberly Tripp. I've been working with SQL Server since 1990. It's been a long time that I've been working with SQL Server. I really enjoy it. I really don't mind any questions at all. My background tends to be design, architecture, indexing, performance tuning, statistics, optimizing procedural code. My kind of common joke is, I don't care what you do with the data, but I'm going to store it, I'm going to make it efficient and effective, make it recoverable, highly available, but I don't care where it goes. So I tend to focus on the back-end server engine. I tend to focus on indexing is probably a pretty high piece of the puzzle, I think, and probably partitioning is one of the most common things I've been doing architecturally and consulting-wise in the last couple of years. You guys are having to keep more data around longer, and you're needing to deal with that data, and it's becoming challenging. So how do you deal with that? And partitioning is a really important solution. But when I had to choose which topic to discuss, I thought procedures might be the most effective for you guys. So SQL skills, if you're not familiar, just super quick. We do training, consulting. We speak at a lot of events. We have a lot of blogs. The folks on the team are on Twitter. Depending on how much we drink later, I can tell you the SQL Pool Boy story. But there's definitely a lot of fun that we have in SQL Skills and a really, really good team of experts that are, like I said, even on Twitter. So if you use the #SQLHelp alias, you'll usually get a really good, fairly quick response if you can put your question within 140 characters or less. That's probably the biggest challenge. So in-person training, immersion events, and I know that they're giving out a bunch of swag, and so I'm going to also add this to the pile, which is $500 off an immersion event, if any of you guys are interested. So I'll throw that into the pile of swag. They're really fun. They're definitely immersion events. We go from 8:30 to 5:45 for 5 straight days, and we have evening events 3 out of the 4 main nights of the event. So it's pretty intense, but really focused, deep technical training, and there's 6 different 5-day events. But I'll leave all that for the website. Online training, we've just partnered with Pluralsight. So I don't know how many of you guys use Pluralsight. The pricing is so phenomenal. You should at least look at it. It's amazing how much content exists there that you can literally even download to your iPad depending on the plan that you choose. So you can watch it offline. And our entire team is already recording courses. My first course will be up in a few weeks, and it's a database design mistakes and solutions course. And it's all about a lot of the things that developers don't think about. In fact, that was the first thing I wanted to talk about tonight. I find that a lot of people get really wrapped up in new features. And I know we're on a Visual Studio 2012 launch, road trip, and that's cool. You need to know the new features, and some of the new features will make things incredibly easier than they've ever been before. But I do find that a lot of people get wrapped up in new features for new features' sake. They don't go back to the basics. They don't think about, basic database design. They don't think about their keys. They let SQL Server defaults become the norm, which is horrible in a lot of cases. So I just want you to think a little bit more when you're creating those tables that sometimes getting that application done and dealing with performance later isn't the best way to do it. I mean, how many have heard that? Let's just get it out there and we'll deal with performance later. I hear that all the time, and some of the things that you really need to go back and redesign, if you have to change the schema, you end up having to change all the code as a result of that, which is really problematic after you're already in production. And yet some design techniques, if you had chosen them early, they're very easy to do early, really hard to do late. So that's going to be my first course, is database design mistakes and solutions, specifically for the foundational basic things that everybody should do. I wouldn't say it's introductory or basic as a course. It's probably more 300 level, but at the same time, it's all those core things. But I wanted to start with that. Never say never, never say always. It depends is kind of our SQL skills motto. I find a lot of things in SQL Server. Sometimes I want to work one way, but in other environments I might want to do them differently. And stored procedures are the perfect example. A lot of people think that pre-compiled code is the reason to use stored procedures. That's actually an okay kind of reason to use stored procedures, but the fact that SQL Server pre-compiles and chooses the plan based on the parameters that were used on the first execution, I'll define that a little bit further, is good for the first execution. It's called parameter sniffing. Parameter sniffing is good. But if the parameter that was sniffed is not a typical parameter, or if the result set from that stored procedure wildly varies, then the plan that was compiled, the plan on which they optimized, right, and the parameters on which they optimized might not be good for all the subsequent executions. And so what you might end up having in cache is a plan that's really not good for everybody. And the irony, the thing that's really frustrating, is that you might have 15 or 20 different parameters that go with a particular stored procedure. And most of the time, the plan that gets into cache might be a good plan. But occasionally, things seem to be slow, and you have no idea why, and you get really frustrated. And I bet this is what's happened. Like, stored procedure X is really slow. Must be stats. That's almost always what I hear. Gotta be stats. Well, go update the stats on table XYZ. Somebody updates the stats on table XYZ, and then the procedure is better. So then, the thought is, oh, it must have been stats. What's interesting is that the side effect of updating statistics is that they will invalidate the plan. So then on next execution, if a good, more typical parameter gets used, then the plan that'll go into cache might be the more typical, better plan, and then all of a sudden, you think updating stats solved the problem, when in fact it was only the recompilation that solved the problem. But there's still a bigger problem here. You're not consistently getting a good plan in cache. How do I do that? What are my options? And again, for those of you that know me or have seen me present, I can talk for hours, really quickly. So I'm trying to do this in about 20 minutes. So parameter sniffing, just to give you my insight, and I'm sure they'll let me go a little bit longer without the big cane.
How would you stop you?
I know. See, once I'm here. All right. So let me just give you a quick overview of store procs, and then I'll do the demo. When you guys create a stored procedure, not really all that much happens, except they put details about that stored procedure into the system catalogs, the metadata tables. That's not really that interesting for most of us. What's really interesting is that no plan is ever permanently saved on disk, and no plan is generated at all at creation. On first execution, or really a better way to phrase it is kind of as I have done on this slide, when you execute and there isn't already a plan in cache, then that first execution will generate a plan. And it's those parameters on that execution that dictate the plan and get saved in the unified plan cache that then get used for subsequent executions. Is that good? Is it bad? Well, it depends. It might be great. And you know, I could probably give you a way to easily recognize where it might not be great. If you have a stored procedure whose result set wildly varies, sometimes it returns 2 rows, sometimes it returns 4 rows, sometimes it returns 10,000 rows, sometimes it returns 100,000 rows. Like if you have wildly varying result sets, that's kind of a ding, ding, ding. You know, that might be a procedure whose plan might need to vary with those different result sets. Does that kind of make sense? Because if you have different result sets, to get 1 row, it might be good to use an index, for example. But to get 100,000 rows, it might not be good to use that index. It might be better to even sometimes do a table scan. scans aren't always bad. See, that's the always never thing, right? I mean, if your query is select star from table, no where clause, table scan's not a bad thing. You know what I'm not saying that's a good query, right? That's a different problem, but you know, it's hard to say always and never in SQL. And stored procedures and compilation is a big one, okay? It's not always good to have a compiled plan, and it's not always good to recompile on every execution, because recompilation has a cost in CPU. So what we've got to do is actually figure out what it depends on and how to recompile the smallest amount possible to give us the biggest gains. Now, my lecture on this in like one of the immersion events where I do this is actually a day long. Okay, it's actually, there's a lot more than I'm going to discuss here, but I'm going to show you one of the more common ways to solve the problem. But be careful, because even though this works really well, you start to add costs if you kind of go the direction I'm going to go for everything. You don't want to do this for everything. I know some of you, I had one person that said, yeah, we're gonna immediately check all of our stored procedures. And I thought, how many procedures do you have? 26,000. And I thought, okay, that's going to take you a little while. And they actually almost jokingly said, well, we should probably go through them alphabetically. And I was like, really? Do you not know your data any better than that? You know, some of you guys will already know which procedures are giving you grief. Some of you will already know which ones have wildly varying results. Some of you will know the ones that have very inconsistent execution times. Or some of you will use the DMVs to actually look at min, max, and average procedure runtimes, where you can get that from the DM plan cache. So there's information that is available to you to kind of figure out where to go. You want to focus on the ones that take the longest amount of time and have the wild, varying results. And then you've got to do a little bit of analysis to figure out what to recompile. Okay, so reusing plans can be good, but it can also be very bad. And one of the quickest things to do, instead of updating stats, is to do an SP_recompile. I know it's at the very bottom of the slide. How many of you know about SP_recompile? One of my favorite little simple things that you guys can do, you have some procedure that's got a horrible plan, or you don't even know that. Let's say just horrible performance and you're not sure why. What you can do is SP recompile procedure name, and that doesn't actually recompile anything. It invalidates the plan, and then on next execution you'll get a new plan. Simple, way easier than updating stats. I'm telling you, you have weird, unknown behavior, unknown performance for a particular sprock, SP recompile. Absolutely. SP recompile table name, which sounds really weird, invalidates all plans that access a table. However, SP recompile table name requires a schema mod lock. You can get some weird blocking behavior there if you've got any long-running operations. So be a little careful with SP recompile table name, but it's still really useful. So those are kind of quick things to try if you're having some weird behavior and you're not sure why. Before you go and update stats, it still could be stats. But updating stats can be very expensive because we have to go and read data and basically build temp tables and cache to build the histogram and the density vector and so forth. So instead of doing the expensive thing first, do the cheap thing first. If this works, then you have kind of a temporary fix. How do you fix it permanently? You have to be choosing, actually strategically choosing to recompile so that you can re-optimize the thing that is not getting an optimal plan. And these are synonymous. If you ever want to re-optimize, you have to recompile. If you recompile for any reason, you get a new plan. You re-optimize. So the question is, how can we recompile the smallest amount of information so that we do get a benefit from having some pre-compiled information with our sprock, but we end up recompiling for a statement so that we get better performance for that statement. Maybe we don't even save a plan for that statement. So the way to do that is really, you've got lots of options. I could create a procedure with recompile, but the whole thing will be recompiled on every execution. That's expensive, not my favorite. I could strategically execute with recompile. I laugh because in the books online, it used to say, if you're going to execute an atypical parameter, execute with recompile. So how many of your users you think are sitting there going, Well, I think this is atypical. I mean, like, I just don't see that happening ever, right? But it's great for testing. I use it a lot for testing. When I'm testing a procedure, I test the 0, the 1, and a few of the different many cases, right? This is testing 101. I test them all with recompile, with recompile, with recompile, and I check to see if the plans match. And really, all I have to check is pattern matching. I mean, you can give this to your 5-year-old and say, do these match? Like, I don't even care what the plan is, just is the plan the same? And if the plan's not the same, then that's where I have to think about a different strategy. And that strategy is generally going to be one of the statement-level recompilation options. And the easiest ones are the ones that they introduced in 2005 and 2008, but I'm still surprised at how many folks don't know how flexible this is. But here's the problem. Nothing jumps out at you as a developer that you even need to know this. You know, we think that SQL Server, to an extent, is kind of set it and forget it technology. It can do anything. But that's its kind of Achilles heel. It's a general purpose RDBMS. It can do anything. So is it going to do everything optimally? That's a challenge. But you can control it better. And you have to know that you need to do this. So your option really is to use one of the statement-level recompilation options. And there's 3. 2 have been around since 2005, option recompile and option optimize for. And the one that they added in 2008, optimize for unknown. And I have to admit that as of 2012, they've actually even improved some of the behaviors around like option recompile. There's some weirdness around what I call multi-purpose procs, but they've gotten better with that. So these options are really good ones to look at. If you recompile like option recompile on every execution, then you're going to pay a little bit of extra CPU. So you have to be careful. I don't want you to go back and then think this is a silver bullet and you're just going to put option recompile like in all of your stored procedures. You should really very strategically use this where you have this problem. So this is where I want to show you a quick demo. How am I on time?
Over.
So, my demo. Okay. So, I'm going to, I'll be quick. Okay.
Keep going.
It's very cool.
Go, Kim. Go.
I know.
You okay, Pete?
All right.
Yeah.
So I'm going to use a database called Credit. You can download it on SQL Skills. I will make sure on my blog I'll put a link to it so you can get that. And I'm just going to show a very simple kind of scenario where I update a row to have the last name of Tripp. I create an index so that I can search for last names of Tripp really easily. And then I'm going to create a really lame but interesting procedure that has a parameter of last name, and then my query basically looks for that particular last name. I mean, it can't get really simpler than this, but here's the point. I'm going to turn on IOs, I'm going to turn on graphical show plan, and I'm going to basically run this with a, oh, hold on. 2012's keystrokes are still driving me mad. Did I not highlight? Oh, no, I just had a typo. See, I did this in the back while you guys were talking, so. Okay, so, and I turn on show plan. Okay, let's see. I might have turned it back off, but here you go. Prog with parameter Tripp, and let me turn on show plan. Okay, so I just executed this with the last name of Tripp. There was one row of Tripp. There was an index to find the last names of Tripp, and you can see that I used an index. In fact, that index is the member name index. We did a seek into that index right there, so that's the easiest, most effective way to get into the index. And then we went back to the table to look up the corresponding data row. That's often referred to as a bookmark lookup or a key lookup. So that's what it did. Really cheap, really easy, because my query only returns one row. But what's interesting is that's the plan that's now associated with the stored procedure. I could spend time showing you how statistically they gathered this information. Looking at Tripp, it says right there, there's one row. Now you can see all of my other data. It looks a little bit weird. But just go with me for a second here. There's one row that matches Tripp, and in fact, if I go back to the plan for this, you can even see where they estimated one, and they got one. Okay, actual number of rows, estimate. Okay, everything looks good there. Okay, but now I go and I run with Anderson. I always think, Mr. Anderson. All right. So I run with Anderson, and I look at the plan, and it does an index seek and a key lookup, and you know, my table only has 10,000 rows. This ran really fast. I might not think anything of it. But if I actually go over, again, to that plan, I can see that the estimate is still 1. The actual was 385. That, you know, if you don't know your data very well, you might not even recognize that as an issue, but I can guarantee that in this particular case, that's not a good plan for this particular parameter, for this particular actual number of rows. Having said that, I can see one other thing. Let me show you one other thing here. If you guys use the properties window at all, I'm a keystroke person. I hit F4 to get that properties window. And let me pin it so we can look at it for a second. You can also see in here parameter list. And I'll zoom in. The parameter that was compiled was Tripp, and the value was Anderson. There's nothing there that's really going to jump out at you where you're realizing that that's a problem unless you look at that estimate and actual and you start to see that they're way off. Now, some people would go, oh, statistics must be bad. And they'd update stats, which would invalidate the plan. They'd run with Anderson again, and then it would do a different plan. They'd go, see, it was the stats. When it wasn't the stats, it was the updating of stats which caused the invalidation, which recompiled the procedure. I could even, oh, now they're going to kill me. I'm going to do a tangent. I could even, like I was telling you guys, I could do a quick SP recompile and show you that just doing that, okay, and rerunning, okay, gave me a different plan. I didn't update stats. I didn't have to go through all the work. I just did the recompile and I got a different plan, and I can see that this plan had my estimate and my actual correctly this time. Okay, so what's my problem? Okay, my problem is that I have a statement that varies on execution. The number of rows returned varies. So ultimately I have options. One of the simplest options is just to tell SQL Server. Now imagine that you had 400 lines of code and there's really just one line that's kind of tied to these parameters. You don't want all 400 lines to get recompiled. I can go to just that line and I can say, you know what, don't keep a plan for this. And that's really one of the simplest recommendations I can make, is you can go over and add option recompile into that procedure just for that one line of code. Again, imagining that it's much, much larger. And is that the first? No. Okay. So I execute with Tripp and I'll get the index plan, right? If I execute with Anderson, even though it's immediately after Tripp, I don't have an issue because this time I get my scan because it recompiled. Now, some people, as soon as they start having parameter sniffing problems, see this as like a Band-Aid to fix all problems, and they start almost using it like a sledgehammer. You know, oh, poor, option recompile, and they start recompiling everywhere. That's not really the direction I want you to go. I want you to be very strategic with this because recompilation has a negative, right? And then it has to go through that optimization on every execution. So use this in the procedures where you really are having inconsistent performance and they're taking multiple seconds usually to run, okay? And that's going to be a large number of your procedures, but you're going to have to watch that CPU on your servers because the more and more you do this, the more expensive it's going to get from a CPU perspective, okay? Now, I could spend hours on this. I do have more stuff in here. There are ways that you guys could use a kind of specific value and tell SQL Server not to sniff, right? Instead, if you know Anderson is the more common kind of parameter that generates the plan that you know is the more likely plan, you could put that in. But be careful, because if you don't know what you're doing, you could also kind of shoot yourself in the foot here. But what you're doing is saying, don't sniff, look at this value, figure out the plan for this value, and put that into cache no matter what. So that's interesting, but be careful. Again, you could really shoot yourself in the foot here. I like this much better than hints, though, because this isn't forcing a particular index or a particular plan. It's just forcing the analysis based on a value that even as the data changes, the plan may change, and that might be more representative for your environment. So I do kind of like this, and it won't recompile every time. It only recompiles that first execution when there isn't a plan already in cache. So you get compiled benefits from it, but you get a plan that's maybe, let's say, more likely and more stable. And the last option, one more, sorry, not really. But the last option, really quick, is optimize for unknown. First time I saw this, I went, what? Like, this was the weirdest name, because I went, optimize for, well, I don't know. Just do whatever you want. I thought this was the weird. They should have called it optimize for average. Instead of sniffing a value like Tripp and going into that histogram and it said Tripp was 1, they actually use a piece of the statistics information that most people don't know that much about. It's called the density vector. And they go to this density vector, and I'm going to simplify this too, which has averages. So they go to the density vector, and the density vector says the average number of rows for a last name, without looking at any specific last names, is whatever. And they optimize based on that average as an unknown. Right? It's not unknown, it's an unknown value, but it's not an unknown number to SQL. SQL has an average that they have in this thing called the density vector. And this one is optimize unknown. And you can see here, what's interesting is Tripp is actually the anomaly. So when I optimize for unknown, right, you can see I got the same plan each time. And the thing that's interesting is I got a value of 370.37, even though, of course, for Tripp there's only 1. And you can see that, exactly where that comes in. I chose this, where did I put my show config, or not show config, show statistics. I wasn't sure I was going to show you that, but I'll just do that really quick. Oh, that's histogram. You don't want the with histogram if you want to see the density vector, but check out this number. The density value, all density times rows, and I chose a table with 10,000 rows because I figured 9 o'clock at night, got to keep the math fairly simple, right? So, 10,000 times 0.0370 is 370. That's where that average came from. The average number of rows over all the names is 370, and it's because most of my names do have like 380 rows. The data was generated and just generated through a loop, but it's interesting because Tripp is the anomaly. So let's say most of the time the names would be needing a table scan. So maybe I'd want to put into cache a plan that wasn't tied to Anderson, but was instead tied to the average. That's what optimize for unknown does. Okay? And like I said, my second course with Pluralsight is going to be about an 8-hour course on procedures, plan cache, dynamic string execution, SP execute SQL, and why ORMs can be very evil. Okay? Sorry. Okay. So, I'm going to do that thing next. Does anybody have any questions while we're getting set up for that?
Yeah, we're ready to go.
Okay. Any questions though, real quick? Yeah. So option optimize for unknown doesn't touch the statistics, doesn't update the statistics. It just uses the density vector. But if the statistics get updated, and therefore the density vector gets updated, it would still cause invalidation, and then they would recompile on next execution. So they are tied together. Although I have to admit there's one other weird gotcha there. Updating stats doesn't always cause plan invalidation. If you guys are not leaving the database option, auto update stats on, you can have very weird behaviors when you manually update stats because it doesn't do plan invalidation. I'm going to put on my notes to add a link to a couple of blog posts that explain that scenario, but I do have to admit I recommend auto update stats to be on. So if any of you are turning that off, realize that you could be really shooting yourself in the foot for plans. So I'm just going to write Aaron's blog post. But yeah, go ahead.
Do these techniques also apply to the cache query plans if you're not using store procedures?
Yeah, so this is really interesting. The question was, do these also apply to cached query plans? Well, yes and no, okay? If somebody is running a statement that's completely and totally ad hoc, SQL Server does something, this is part of why it's a full day. SQL Server does something called auto-parameterization, where they will actually look at the statement and then they will fork. They will basically go, is the statement safe or is it not safe to parameterize and put the plan in cache? And let me start by saying, if all of your statements are truly ad hoc, you'll probably get almost no plan reuse. Because one of the rules on the whole safe unsafe is if the query has more than one table in it, it's not safe.
Oh, wow.
Hello? No, I mean, come on. Like the first time I read that, I'm like, well, okay.
So you mean any query then?
Any query,
Wow.
pretty much.
That would be all of them.
It's, yeah, the only things that get auto-parameterized and reused from an ad hoc perspective are like the really simple, select from a table where clustering key equals value, you know, like really about as basic of a statement as you could get, which those statements are usually not expensive anyway, so who cares, right? Like you look at that and you go, so what is all this auto-parameterization? Garbage, okay? Garbage. Truly garbage. So, sorry. Then, I'm just the messenger, right? So then people start realizing that, and they say, I've got to get these statements to be auto-parameterized. And they learn about SP_execute SQL. Because that really should have been labeled in the books online, forced statements caching. And you know what? It does exactly the same thing stored procedures do. On the first execution, it sniffs the values, puts a plan in cache, everybody reuses the plan. If it's stable, great. Not every statement is stable. Now, if you're smart enough in the application to use SP_execute SQL and then go, well, this one is atypical, you can tack on option recompile in the statement you send across. But my problem is, the people using SP_execute SQL aren't sitting there in the client going, maybe I should recompile. Like that's just generally not the case. But when I'm creating and developing apps on the server and I'm writing server code, I'm expecting that the database developer that's doing that knows a lot more closely about the data, the distribution, when it should recompile, when it shouldn't. And that might be a bad assumption, but with ad hoc and ORMs and SP_execute SQL, you have the ability. It's just, in my opinion and my experience, not likely that it's getting used like ever. And so you end up with the same kinds of problems. It's a great question.
Thanks.
Sorry.